Hello everybody, and welcome back to the Poor Man's Chemist. In this short little video, I am going to show you how to make a chemical curiosity that I found on Wikipedia on the cesium chloride article. If you look at that article, you'll find there's a section labeled the analytical chemistry. And apparently it was, I don't know if this is still used a lot or not anymore, but one technique in analytical chemistry looks like just various metal cations or cations, was to react them with cesium chloride and different, usually a couple of other reagents, and see if you got a precipitate or not. And then depending on what was in solution and what you used and the detection limit and all this, it would precipitate out usually a complex, although sometimes a double salt. And you could use this precipitated solid to, I guess, both, identify the stuff that's present and probably measure it as well. Since, the solubility for all of these things is rock bottom. It's talking about detection limits like, 0.1, what was it, 0.1 micrograms per mil or something like this. So if that's the case, and detection is precipitation, then most of these things have to be wildly insoluble. I am going to make one thing from this list, which is cesium, well, technically it's dicesium, Pentaiodobismuthate 3. I fooled around with this reaction a couple of times. I've tinkered with it. If you just kind of throw everything together, you get a red solid like you are supposed to. I'm not going to be quite so haphazard in this video, though. I'm going to use the proper stoichiometry to get this. Information on this compound and the other compounds that are like it on the internet is scarce, man. When I checked the source on Wikipedia for all of this information, it was in Russian, which I can't read. And which actually was really disappointing because I wanted to see what source all of this cool shit came from. Because a lot of the compounds it describes are actually really neat. And every one of these reactions that I have tried, with only like one or two exceptions, has worked out beautifully. So, yeah. I don't know. Most of the information I can find on the internet about this compound appears to be in Russian, at least the stuff that I saw. The stuff that is written in English is a little... Well, there was a paper that came out in 2005 where somebody was talking about a similar compound that I did see this formula come up all over the place. It was tricesium non-iodobismuthate. For any of you that are avid fans of this channel, that you may remember tricesium nonachlorodiphthalate, which was, so far as I know, the only example of the nonachlorodiphthalate ion. It's the only compound I know of where it occurs. Well, this is kind of true for this too. I've only ever seen it with cesium or, I think it was tetramethylammonium. So you kind of need a big cation. But it was, non-iodobismuthate. And the structure for the ions is essentially the same. So I thought that was also very curious and weird. As for the compound that we're going to make, it is a nice, vibrant, orangish red. And if you want to see an example of it, there it is, because I kind of fucked up, and I did this once before because I wanted to dry it and see how it would behave after it dried, and I dumped that shit out, and so there you go. I decided to make the best out of this situation, though, and I left this sitting out in the rain. Now, the freshly precipitated compound, before it dries, will dissolve in copious amounts of water and appears to hydrolyze a little bit. But once it's dried, man, now it is much more resistant to that shit. Because this sat out in the rain all night and the color is still there. also interesting because, again, you know, this science, we seize all opportunities. This is the paper towel that I used to wipe it up with. Now, why am I showing you this? Well, after wiping it up, I hung it up and let it dry just to see how this stuff would actually do as a pigment if the dry powdered compound is mixed with water. And there you go. Actually, it does a really decent, like, reddish orange color. More orange than red. I don't know if the camera is showing you that. Although, over here, it looks more red than orange. I don't know. Maybe you need a thicker layer of it. But, I mean, hey, as a pigment you can make yourself, it is pretty cool. I don't think this stuff is overly toxic. Now, I don't know. That is just a wild guess. It could be very poisonous for all the fuck I know. It stands to reason that it kind of would be. I mean, any bismuth salt that can dissolve in stomach acid is probably not going to be great for you. But, I mean, bismuth does have a markedly low toxicity for a heavy metal. That's not to say it is benign, just, I mean, I've been working with this with my hands and not really, you know, other than just washing them before I go to eat something. I mean, not doing anything particularly, you know, it's stringent to try to prevent myself from coming into contact with it, and I've had no ill effects whatsoever. So it seems to be, I hate to use the word harmless, but let's just say that so long as you're not eating it or, you know, snorting lines of it or making face paint out of it, its danger is probably minimal. Okay, so in order to make this stuff, it is very, very simple. We're going to take some bismuth nitrate that I've got here. This is 2.4 grams of it because that's just what I happen to weigh out. Put that up there. There we go. Alright, let's move this over here. Cool. Alright, bitchin'. Okay, so, first things first, bismuth nitrate will hydrolyze to the oxide if, at least I think it will. It definitely hydrolyzes to something if you mix it with water. So we are going to have to mix this with a little bit of hydrochloric acid first. Just going to use a little bit here. Don't need very much. And we're going to add a little bit of water to that. Okay, we're going to let that all dissolve. Let's see here. You guys can see things a little better than that. Yes, the tripod is just as cheap as the camera, guys. It's not called the poor man's chemist for nothing. Alright, now, the next thing that we are going to do is we are going to take 5 molar equivalents of potassium iodide, and we are going to dissolve this in some water. Now, we are going to take some cesium chloride. Got that here. And we are going to dissolve this in some water. Okay, stir that up. Okay, now, the order in which you add these things, I think, makes a difference. I'm not 100% sure. We're about to find out. This is the potassium iodide. In theory, that should be potassium pentaiodobismuthate. Very pretty color, right? You focused, you piece of shit. Alright. Now, this will be the acid bismuthate, at least based on the stuff that I was reading. That looks to be the case. Alright, so now what we're going to do is add the cesium chloride to this. And that precipitates out our product. There we go. You can see it's a very nice color. God, this thing just does not want to focus today. It is more red on camera than it is in real life. In real life, this one turned out a bit more orange than the last one. Whatever. 6 of one, half a dozen of another, right? And that's pretty much it. All you would do now is just filter it off and dry it, and you will have cesium pentaiodobismuthate, in theory. Okay, everybody, here is the final product. The camera is making it look far more red than it actually is. In real life, this is clearly like slightly reddish orange. I would absolutely say it was more orange than red. But anyway, what I am going to do now is allow this to dry out overnight in the desiccator, and we will take a look at this in the morning. You can see here, this is the filtrate. It has kind of a yellow color. I mean, we reacted stoichiometric amounts of stuff. I'm not sure what's up with that. Perhaps some portion of this is soluble, which would kind of match up with what I've seen. Before this stuff has dried out, if it's anything like the previous run I did, then it will dissolve in copious amounts of water. So, anyway, I'll come back in the morning when this is done. Okay, everyone, this is our final product. It spent a couple days in the desiccator because I went up to my mom's place for New Year's Day yesterday because I couldn't go up there for Christmas because they got a shitload of snow. And as anybody that's talked to me on Discord will know, I can't do much in snow except wreck on it, so I didn't even try. Anywho, this is what we have got. Look at that. It is absolutely fucking beautiful. That is great. Doing it in a stoichiometric mix definitely gives you a better product. I don't know, I guess, honestly, the camera is pretty much capturing it exactly as it is. Maybe making it slightly more red, but not by much. So, there you go. Dicesium pentaiodobismuthate 3. That's some cool shit, right? So, if you liked that video, give it a thumbs up, and if you didn't, whatever. Subscribe, comment, share the video, donate a few bucks if you can, and until the next one, I'll see y'all later. That is so beautiful. That really is, man.